Can you guess what a nonstick pan, a jacket, and sometimes floss may have in common? No? Well, they contain a special and synthetic chemical that is resistant to environmental degradation and nearly indestructible. Now, although these chemicals have impressive qualities, they have caused major health concerns over the years. Various environmental and public health agencies have revealed the impacts of these substances, which has also been linked to reproductive issues as well as liver and kidney cancer. So today, Public Health investigates per and polyfluoroalkyl substances. Whew, say that 10 times fast. According to the EPA, PFAS is the term classified for a group of forever chemicals that can make consumer products like these resistant to water, heat, oil, and grease. So let's dive into my organic chemistry notebook to get a closer glimpse at these chemicals. Here's an investigation profile on PFAS. Let's discover how PFAS chemicals are manufactured and learn more about 3 of their chemical properties. PFAS chemicals can be further broken down into polymer and non-polymer categories. Today, we're focusing on the non-polymer category that includes polyfluoroalkyl acids, PFAAs. The first property. PFAAs are made primarily of carbon-fluorine bonds, the strongest covalent bond. Due to the higher electronegativity, the fluorine atom takes up most of the electrons, then induces a positive charge on carbon, and voila, opposites attract. The greatest love story ever told. We can think of the fluorine atoms surrounding the carbon chain acting as a defense, preventing other suitors from reacting with this one true love, attempting to break them apart. Aww, so sweet. Although other PFAS molecules with non-fluorinated weaker bonds can degrade, they will turn into PFAAs, which are more stabilized and likely to persist for longer periods of time, making PFAA chemicals extremely resistant to environmental biodegradation. The second property. Perfluoroalkyl acids are made up of 2 things, a complete fluorinated chain and a functional group. The most common examples you may have seen are PFOA and PFOS, but because the heads of these acids are negatively charged, they're likely to absorb and interact with positively charged molecules. This property of PFAAs makes these chemicals water-soluble, and when they enter a drinking water supply, it can pose contamination challenges. The third property. Due to the configurational similarities of PFAAs to fatty acids, PFAA molecules can mimic these biomolecules and infiltrate your body. Although scientists don't totally understand how this works, when you're exposed to forever chemicals from the air, water, or food, the carrier proteins for fatty acids can also pick up PFAAs. When people are heavily exposed to these chemicals, they can accumulate in the body and threaten our natural regulation processes. Phew, that was a lot to review, but there's still so much to learn. I'm so excited about the direction that innovative science is taking us in the future, but it's also really important to be cautious of the things that currently pose a threat to the health of society. And although there has been some progress in regulating PFAS and filtering them from contaminated water sources, there's still so much work to be done to bring awareness and find safer alternative solutions. So, the next time that you're looking to buy a nonstick pan or maybe even a water-resistant jacket, be mindful of the materials that are in it. Be sure to check out my resources for more information, and this was Public Health Investigates.